Hey, welcome to the Rescue Lab podcast. PJ Halloran here with Jeff Quinnell from the U.S. Army Corps of Engineers. We welcome him into the IUC studios where we're going to talk about the Structure Specialist program within FEMA and the U.S. Army Corps of Engineers today. So Jeff is a National Urban Search and Rescue Program Manager for the U.S. Army Corps of Engineers with over 31 years of service to the Corps of Engineers. Jeff has a wealth of experience in civil and structural engineering. He grew up in Lakewood, Washington, and earned a bachelor's degree in civil structural engineering from Seattle University. His career with the USACE has taken him to various districts, including Portland, Seattle, Fort Worth, and Sacramento, where he's been involved in a wide range of military and civil design projects. In 2005, Jeff became a member of the U.S. Army Corps of Engineers Structure Specialist Cadre and began supporting its training program in 2008. He was promoted to his current role as the National USNR Program Manager in 2017, based at the South Pacific Division. In June 2025, Jeff moved with his wife and stepdaughter to Huntsville, Alabama, where he now manages the program remotely from the Redstone Arsenal. Throughout his career, Jeff has been deployed to numerous disaster sites as a structure specialist. His deployments include Hurricane Ike, the Haiti earthquake, the Champlain Towers collapse in Surfside, Hurricane Ian, and the California wildfires. Jeff, I want to welcome you to the podcast. I know we've been chasing each other for a little bit, but I appreciate you. I appreciate you being with me here today, and welcome in once again. So we'll get right into it. For people unfamiliar with the structures specialist role, what does a structure specialist do on a USAR deployment?
Okay. Well, yeah, the structure specialist is basically a structural engineer that goes through intensive disaster engineering training. And in general, they bring engineering expertise to search and rescue. The main job is to keep rescue teams safe so that they can focus on the rescue efforts and saving victims. We're generally out there assessing the stability of a damaged building, looking for hazards. We might be monitoring that for movement, in designing temporary shoring to hold up the structure. We basically enable safe entry and safe mobilization across a disaster site.
And how did you personally get involved with the Army Corps of Engineer Urban Search and Rescue Program?
Well, it started back. I actually had interests early even in high school in engineering. It started back. I have an identical twin brother, and my folks.
You're not pulling a fast one on me, are you?
No, I'm not. Nope. We're identical technically, but we don't look so identical these days. But generally, my folks weren't sure if they'd be able to put two kids in college at the same time, and so my backup plan was to become a firefighter. Nice. So I took all the tests and did really well. And unfortunately, they neglected to include the funding element on the levy that they were trying to pass in the city, and it didn't get put on the ballot at all. And so they weren't hiring. I was at the top of the list, but ultimately we were able to get the financial aid and went to school and went into engineering. And so to get involved in this program, once I started working for the Corps of Engineers, I had transferred to the Seattle district, and my cubicle neighbor at the time was on the search and rescue team, and I just heard him talking to people on the phone, and I asked him directly because that piqued my interest, because I had interest in building things as an engineer, but also had that fire service interest, and so that piqued my interest, and learned about it. And the Corps of Engineers actually, while we have this structure specialist cadre, we run the training program that trains all structure specialists. And just a little bit more on the structure specialist position is that's a formal position on a FEMA search and rescue task force. And so the Corps of Engineers, while we have a cadre of, currently we have roughly 30 across the country, and FEMA is typically able to handle disasters like hurricanes and tornadoes and flood responses and wide area search type scenarios without a whole lot of disaster engineering support requirements. But they do have 2 structure specialists per task force. So if it's a large scale collapse, earthquake, or multi-story complex collapse like Surfside, then you're going to need more engineering support than those 2 per task force. And that's when they call the Corps to tap into our resources to augment their teams.
I was going to say, so they can call on you exactly to augment whatever their capabilities are.
Right.
Gotcha.
And it's, the training that we go through serves us well in supporting some of these emergency support function 3 missions, like the critical infrastructure assessment teams and debris missions and things that might need some structural engineering support as well, since we have a bit more intensive training than those teams that go out for those types of missions, that they can get our structural engineering resources really quickly and rapidly deploy for that support as well.
So you talked about the training side of it on the structural specialist side. What is the pipeline to become qualified in the role that you're in?
Yeah, it's fairly rigorous. It involves the position requirement itself requires at least 5 years of structural engineering experience. Requires that you have your license, and so you'll have that educational requirement. And after you're entitled, you can get your PE license after 4 years of actual experience. And so there's other elements that help candidates become a structure specialist, but those are the base requirements, is that experience and licensure. Once you've got those, then you're eligible to attend the certification training that the Corps of Engineers puts on, and get certified to serve in that formal structure specialist role that supports the FEMA teams.
Okay. And what skills or mindset separate a good structure specialist from a great one?
Well, it all comes down to mindset, and you can imagine that the stereotypical engineer is not necessarily cut out for this kind of thing. It takes a different type of engineer and mindset to actually put yourself in this kind of role. It's a good STS has the technical skills, but a great one is driven kind of by that service mindset, the humanitarian mindset to perform under extreme pressure. In the civilian world, the engineers play defense. They follow building codes and they perform multiple design reviews and avoid risk. But at ground zero, you have to play offense, and the structure specialist has to creatively and rapidly figure out how to make a dangerous building safe enough to get rescuers inside, rather than just throwing our hands up saying it's unsafe. One of the common things that we bring in training is if a firefighter hears someone calling for help in this nasty collapse site, they're going in. There's no stopping them. And so we never say it's a no-go scenario. It's because nothing is safe when you're going for a collapse rescue operation. And so we call it a slow go. And I can get into that a bit more, but in general,
absolutely.
that's the kind of mindset.
So you have to be able to get. You're not afraid of getting dirty is, I think, a big one on the engineering side. Okay, so in an operational mission, when a FEMA task force deploys, where does the structure specialist fit into that operational picture?
There's a lot of different, management divisions within a task force, and one of you've got your ops folks and your planning and safety, and we fit in and report to the planning team manager. But with boots on the ground, we're hip to hip with the search and rescue managers and the rescue personnel, from the initial reconnaissance to actually going in the hole and mitigating hazards as you go.
Talking about deployments, and in your bio we read that you're well traveled in this trade. The first operational period when things are pretty chaotic at a collapse. What does that look like from your end, arriving on a scene? Especially, whether that's Haiti or whether that's Surfside, or from what you've seen.
So I'll tell you, Haiti was a unique experience because our mission that we ended up being involved with, it was such a chaotic scene. You didn't know what you saw this big mound, but it initially involves a rapid recon and structural triage. We're quickly evaluating multiple collapse structures in some cases to figure out a couple things. Basically, which buildings are most likely to have viable victims, and what is the risk level to the rescuers. And we feed that directly to task force leaders so that they know exactly where to focus their efforts and what resources might be needed for that. So it is a chaotic environment, and so you got to get your head on straight, see what you're looking at. Hopefully you can do some early recon as you're deploying to an incident to kind of get some sense of what you're going to and what potential collapse elements there might be.
What was your experience at Surfside?
Surfside, it was an interesting one. it initially started with that being in Florida. Florida has I believe six task forces. There's 2 federal teams, but an additional 4 state teams. And so they had a lot of local resources that were able to mobilize to that incident. Not as many structure specialists with those. So, each of the federal teams are required to have a certain number, and they did have a good number of them, but that's where they needed additional engineering support, especially when you've got part of that structure is still standing, and with at a great risk, and when there was an unknown cause of collapse and sudden collapse, and so operating and making rescues in that standing structure, we were able to do that from the exterior and make limited entry to assist people to get out, but at great potential risk with that house of cards, essentially, that you didn't know if it was going to be the next thing to collapse. So,
right. I mean, you bring up a good point, because, you have people working around that partial structure that's still standing. What are the biggest hazards that rescuers often underestimate in partially collapsed structures?
I think the biggest hazard is secondary collapse. There's, like I said, if there's people inside, they're going to go in, and so the mindset of fire rescue personnel is pretty focused. It's not, they don't blindly go into a completely life risk scenario to do that, but secondary collapses and working in fall zones, and that's a good example in Surfside. Is that existing structure what had typically we're creating fall zones to operate outside of, that are equivalent to about 1.5 times the height of that building. Well, that rubble pile was completely in the fall zone of that existing structure, and so that risk was taken. There were a lot of people that had ultimately perished in that structure, and so that was a challenging one to enforce, particularly for local teams who actually knew some of the victims in that structure, and so they had a personal motive to working some of these more hazardous areas. And so, but yeah, an aftershock or shifting debris, even just the vibrations of our own equipment and rescue tools could compromise some of the structural elements that are temporarily being held up by a debris pile. And so it's those types of things that the structure specialists can bring some focus to with rescue personnel and team leaders.
And what's the difference? You're talking about Surfside, but you were in Haiti also, where the construction type is totally different. How do you take that into account when you are assessing these structures?
That's, I think in Haiti was a little bit different, because by the time we got there, it was generally very little expectation of survivors. And so while it was such poor construction, poor quality concrete, and we could take some of the CMU bricks that they were using for constructing walls and crumble them in our hand. And so those types of collapses were pancake collapses. And with even the slabs were made out of CMU, not necessarily a poured slab. And so those things, pancake collapsing, just turned to powder. And so there was very little void spaces for people. I mean, there were some early rescues, but the numbers were pretty low. And if you recall, the death toll on that one was massive, and over 100,000. And so it was a huge incident. And but again, we didn't have a whole lot of information on some of the structures we were operating in, and tack on poor quality materials and standards, and adding on this particular structure. We worked at the Hotel Montana, which was one of the nicer hotels that a lot of foreign dignitaries would stay at, and military personnel. And it was a 4-story hotel originally, and they added a 5th floor onto it, which made it even more top heavy on the side of a hill that made it very susceptible. And so these things we learn and get information from building owners and things like that to try to size up the footprint and where voids might be and where people might be. But that, each incident is very different.
Of course.
Surfside, of course, we had piles of concrete slabs that had pancake collapsed, and there were some similar elements to seeing pancake collapses in Haiti. Each one's unique. Yeah.
Yeah, of course. But in that same sense, I mean, you still must have a process that you use. Can you walk us through the process of assessment, hazard mitigation, and shoring decisions along with rescue access?
Yeah, sure. The That process involves, like I said, there's some during the mobilization phase, you're doing some early recon, just electronic recon, so to speak. But once you're on the ground, you start employing that rapid structural triage, identifying based on the incident, if what time of day did it occur. Was it a public school or a hospital or something, or an office building, or was it during business hours? So you kind of assess some of those elements to see the likelihood of people even being in the structure, and what type of construction it is, to identify what kind of void potential there is. And so those are the things that play into the structural triage, and identify a prioritization of which structure should be searched first. Where's the better risk versus reward criteria to weigh into that triage process. Once you identify those priorities, then you do a little bit more detailed assessment. Usually that involves a 360 walk around the entire structure, and you're kind of looking to see what kind of structural elements may have collapsed,
Right.
which are still sound, which, what kind of mitigation measures, how can you get in? Can you hear people? And at that point, once you identify that this is a priority search or rescue structure, then we're now creating mitigation plans where we identify what are the shoring needs, where can we enter the structure more safely, or what can we do to make an entrance more safe, and not create additional collapse risks. That might involve shoring. It might be tying back, what we call widowmakers that are just hanging off a structure and could fall from wind blowing, or just temperature differences that cause some movement. We'll set up monitoring of these structures to, while things are being put in place, like rescue shoring and things like that. We can have kind of a monitoring effort with our structural monitoring tools to identify if there's any movement that is significant enough to kind of blow the horn and get people to evacuate,
Yeah.
if there's a potential for secondary collapse.
So you talked about the structural triage information, and I've heard that in terms of SARCOP or Survey 123. Do you guys have a lot to do with that in that? Because I know that is a growing portion, that structural triage sheet.
It is. We have implemented some of what we do as structure specialists into the SARCOP element, and even some of our structural monitoring with, and that's something that I know back with the planning cell is tracking, what particularly for wide area search, and we do support some of those efforts as well that aren't so much a very technical element, but we use a lot of technical tools and train on those, and so we support the task forces however we can, but SARCOP is one element with the triage that we're identifying. Once we do that triage and identify the risks, the potential victims, and the prioritization, that data gets fed right up to the
Right.
planning and management cell to start deploying their teams to those different structures to make rescue efforts. But yeah, it's very much the SARCOP tools, the monitoring tools, those technical elements
Yeah.
are
Right.
growing,
And
and
how has that changed the game for you guys as well? All the
it's been.
implementation of SARCOP and the structural triage, putting it in the hands of the people on the ground.
Yeah, it's pretty huge, and it's one of the things we learned at Surfside was different elements that have actually helped further develop how we use the tool. Surfside, since it was an unknown collapse, was treated as a crime scene, and so
Right.
all these key structural elements that were trying to identify the cause of collapse. NIST was the outfit that was doing the investigation and needing to do collect evidence for analysis, and so we used basically Survey 123 and Quick Capture to document evidence pieces, where it was on the pile, a photo of it, and that data was very extremely useful to piece that together to perform their analysis. But other technologies, use of drones, robotics. Robotics is something that's getting further developed. We haven't used it with the Corps of Engineers yet, but I know that some tools are becoming more prevalent on state and federal teams. There's always some limitations on what we can do if it's a federal disaster, and you've
Right.
got drones flying. There's some rules against that still, but it's been
We're
an
getting there. We're getting
extremely
there.
valuable tool to
Yeah. I think one of the
basically.
the big takeaways I saw from the Surfside, presentations that I've seen from people who've been there is the use of Survey 123 and the drones and how they would map the debris layer every day of how they were delayering. I thought it
Yeah,
was pretty incredible.
it was. It helps identify, you know, things like what you're figuring out too is the volume of debris that's being pulled out, and you can kind of identify if you've got this much debris that's been removed, you can see what's remaining, and based on the design of the structure, and it's a productivity tool, I guess, as well as far as assessing that and what the cleanup requirements might be and managing debris and things like that as well. But there's quite a wide scope of what drones can bring, and even sending it inside that structure that's still standing
Yeah,
to identify, elements that are too risky for personnel to go into. And so,
absolutely. Yeah.
and that was done at Surfside too. And so
Yeah. No, the future, the future of disaster response is obviously happening right now.
that's
As far
right.
as the,
Yeah,
as
yeah.
far as the Army Corps engineer goes, you guys are a mix between sort of FEMA, the military, and the fire service. How different are FEMA, military, and local jurisdiction rescue environments operationally from your end? What have you seen?
Well, the local fire departments are kind of the tip of the spear, but they generally, like Surfside's a good example. Like some of the state teams were there. Of course, Florida is is right there as well, and they do have a lot of those tools. But in general, the local fire departments, they might not have sufficient gear and equipment for massive structural collapse, and so that's where they try to get additional outside resources to come in. The military teams. Like I don't think I mentioned we support the Army Aviation Brigade has a kind of they're considered the 29th Task Force by some, and it's a rescue engineering company for the Army that just operates in the National Capital Region. So we serve as their structure specialists as well, but they follow a military chain of command and that type of structure, and so that's a little different. It's there is that structure there, and so we come in and they're keen on learning from the FEMA system and the national response framework. But the FEMA task forces, they bring it all together, and they're highly standardized for these type of massive complex disasters.
No, absolutely. But in the same sense, what lessons can a municipal fire department take from federal USAR?
I'd say that standardization lesson, it relies on the standardized job description, training, equipment caches, procedures, and that level of uniformity is what allows completely different teams to mesh together seamlessly for massive, complex disasters.
Yeah, no, I think that is the FEMA team. You know what you're getting when two teams come together from different sides of the country. But on the engineer
Right.
side, how do you you are maybe coming in to augment a team? How do you build trust quickly on scene between engineers and people you've never worked with before? Is it that standardization?
It's critical. I mean, it's when you standardize and you know when we like I'll talk about training as well, but the training is something that particularly when we're working with FEMA task forces, some of the state teams, and those that attend our training, it's all done through the same class. And we actually the Corps of Engineers offers the only training for structure specialist certification out there. There's
Yeah,
nowhere else you get it. So everyone comes to the same training. They train together. They learn the same things, and it's critical to when you've got different agencies on the rubble pile. Everyone needs to be speaking the same language
yeah,
and have common terminology, and so it's critical. And it's something that when you're using the common marking systems and procedures to in the midst of chaos, when you've got that training to fall back on, that really is where the trust is established. And
yeah.
people are these task forces are there's 28 teams across the country. We've got our personnel across the country as well, and you can be a California team supporting in Florida,
Of course.
supporting an incident, but they all go through the same training, and we've seen each other before, and so
Yeah.
we can see a guy on that event and say, okay, I know you. Let's talk, and
Yep.
you can jump right in and work together, and so it's critical, and that really helps with the trust element.
Yeah, and I think just to speak to that point, I think it's such a small community that, if you travel for training, you meet a lot of these people and then to automatically show up and say, "Hey, we have an established relationship." I think that's hugely important in tech rescue
Yeah.
and in USAR deployments. You mentioned training. What does training actually look like behind the scenes for you guys?
Well, the Corps of Engineers, particularly for me, particularly, it's I manage the urban search and rescue program, but part of that is running this training program for all structure specialists, and so it's a big part of my job is just managing the annual training that we prepare and deliver for FEMA, and it's being that it's so unique and that we're the only provider for this training. We do get interest from all the state teams that are out there. There's some that really haven't come through our training program and don't have engineers that support some of the smaller state teams, but we've even had international rescue teams that have come to attend our training with the uniqueness and we got some real high level elite professors and that or even a PhD level professors who are actually in the FEMA system
Yeah.
serving as lead structure specialists for the IST and uh, and different academia, but others that just have been in the system a while to provide the intensive training at such a high level to do that. But yeah, as far as training, it's something that's a continuous effort. We do require refresher training. There's a lot of perishable skills for the
Exactly.
engineer that the engineers are for the FEMA teams. They're generally in a private structural company. It might be their own company.
Yep.
On the federal side, we the FEMA teams. They're structure specialists. They have quarterly training that they'll do with their own teams. The Corps of Engineers structure specialists don't have that team association. We're a group within the Corps. And so we have additional requirements with our refresher regional training that we put on for them to try to maintain those same type of more frequent skills and exercises to sustain those perishable skills.
And on the engineering side, what would you consider a perishable skill? I mean, I know on the tech rescue side, like rope for me is like I have to be in it. It's something that will degrade very fast. What does that look like for the engineers?
Yeah, that's the perishable skills for the engineers generally are some of those more technical ones. Like I said, we're these private engineers that work for their own companies or for the Corps. They don't do this every day.
Yeah.
These monitoring equipment like the total station. Some engineers do a lot of surveying and they'll use it a lot, but most don't do that every day. And especially as they gain more experience and start getting to more administrative or supervisory roles in an engineering company and things like that, they're not doing as much technical application of their engineering. And so those are the things we make sure to cover in depth at each of our refresher trainings. It's something we employ during exercises that we participate in. The SARCOP stuff that's ever changing every year. In fact, sometimes we do 3 refresher trainings per year. It's a weekend regional training in the East, Central, and West FEMA regions, and sometimes between each session there have been a change to the SARCOP
Yeah.
requirements, and when the quick capture and some of the different process field maps and how it's being used and
Yeah.
developing new forms and the whole process. And so you've got to keep our guys, our instructors even have to keep busy with keeping their training materials up to date.
Yeah, it's
And
it's
so
amazing how fast that is evolving and the almost
Mhm.
the daily changes that seem to come out of it. I think from
Yeah.
even the past couple of years, like from what I've seen, the rollout of it to where it's at now, it's mind blowing. And what the future, is going to be of this thing. Um, I don't know. We'll see what happens, I guess.
Right.
But you talk about training and perishable skills, but the importance of training. What makes collapse training or rescue training difficult to replicate realistically?
It's it's difficult to replicate sheer chaos. And so,
Yeah,
when you've got a collapse and you got people crying or you don't even know what the structure even looks like or what it
yeah,
used to look like, and it's the high stakes and the risks associated with collapse hazards. It's difficult to replicate those. A real disaster has those immense time pressure elements. You got sleep deprivation.
yeah,
There's a psychological weight of what that there's lives that you're trying to save, or you might be witness to some awful things, and It takes a mental toll, and it's really difficult to bring that to replicate that in training.
Yeah, that's stress.
We
That.
exactly. I think that's something we actually we do a fairly good job of bringing. Yeah, and that's part of taking an engineer from the office and putting them in a disaster zone. And we have an advanced structure specialist class that we put on too. It's a 5-day training, or is very heavily scenario based. Those instructors that have been in the system and have deployed. One of our instructors is a retired FDNY firefighter who was on New York's task force. He responded to 9/11, for example, and some other big ones like Oklahoma City bombing, and bringing a New York firefighter, and of course your common New York accent and personality and firefighter language,
Yeah.
and you have an engineer come out of a confined space scenario and having to report to this New York firefighter who's in your face. Or what do I need? I need to get my guys in there. What's
Yeah.
it look like?
Yeah, that's
It's
stressful.
these types of these types of things we try to bring to promote that rapid decision making. Something normally we're going back and, hey, let's review this. Okay, we got our 35% milestone. Let's have some meetings, and now we got our 50% milestone. And so it's all
Yeah,
these different time that associated with collaborating, where you need to be really quick on your feet, and you need to look that task force leader in the eye. And if there's a significant risk, you have to be able to confidently explain, this is why we can't do this yet. There's people in there, but you also have this beam that's got a big crack, and it moved 3 inches in the last 30 minutes, and it's holding 30,000 pounds.
Yeah.
And so those type of, I'm giving examples of actual things that have been presented in our class, to where a structure specialist needs to provide that kind of input in a manner that okay, they get it now. And we kind of joke back and forth a little bit. The firefighters call us, put our propeller hats on, and we joke with them, saying we gotta draw them a stick figure picture, so
Yes.
because
Yes, I
to
do need that.
explain
I do need that.
things to them. But it's I think through the years of since this program and since structure specialists have been a formal position, there's been some confidence and better reliance and teamwork and trust that's been developed due to some of those elements that have assisted with promoting safe rescue. And if they go in there and cause a secondary collapse, everything's going to stop and slow down.
Yeah, and I think that
So
goes back to, you said, a slow go kind of mentality. Just take it piece
right,
by piece.
right, right.
You talked earlier about, like, at Surfside, when these smaller departments are responding to these large events, first because it's their jurisdiction. What should these smaller departments focus on if they're trying to improve their collapse rescue capability in those early hours?
Comparison. You know, we talked about the standardization piece and how the importance of that is, but I think there's just some fundamentals that like sizing up and what the collapse is, and hazard identification. You want to identify those right away, and identify what the risks might be with those hazards. If you do need engineering support, there's a lot of times where you're going to identify it, you need some more resource. Surfside's another good example where Florida One was the first team out there for such a massive collapse. And, your structure specialist should be, of course, in retrospect, you look at, okay, nobody was doing monitoring on that right away, and this thing could have collapsed any moment.
Yeah.
But you only had like 2 structure specialists there at the onset, and they're going in to support the teams that are going in to help make operations more safe there. But yeah, learning how to recognize different building types and different collapse patterns. You can imagine a steel structure is going to have a different collapse pattern than a concrete one or a masonry one, and where there might be survivable voids. So if you have some awareness of the types of collapse patterns for different types of buildings, that's important to recognize that. If small departments can master rapid risk assessments and building marking systems, that will make much safer initial decisions and know exactly when to call for those specialized resources.
I think that's important. Those first couple hours probably really make the difference and survivability early on. And these local
Yeah,
departments,
yeah.
local responders are the ones that are going to affect those rescues. On the leadership side, culture side of the FEMA, USAR teams, and even the Army Corps of Engineers, what leadership traits matter most on these teams?
That's it's an important question. You know, think when we talk about the different types of engineers that might be called to, or that might be able to serve in this capacity, they all have to be kind of that type A personality and be leaders. Have leadership experience because you're working in this chaotic environment and having to make quick decisions. Another important element that I didn't mention before was, you might be the owner of your business and the top engineer, your lead guy, and you're kind of the king. When it comes to you make the decisions, what you say goes, and there's an ego element to that. And so when you're this this great engineer with your own business and you've got kind of a ego build from that, and you come to a disaster scene, you're not the boss.
Yeah.
And so you got to check your ego at the door on some of these things, and just have that mindset to where you're going to need to support the team, and in whatever way you can, and be collaborative. And conflicts arise, and
Oh yeah.
and the joke with engineers is, if you've got four engineers in the room and you ask them all a question, you're going to get six different answers. And so it's something that has been an issue on probably most major incidents, when you've got multiple engineers trying to approach a solution, and you having to have that mindset to resolve conflict amongst yourselves and recognize the goal and the support that the task force needs to operate and make those rescues. It's an important one.
No,
Did
absolutely.
I
I think
answer your
that
question on that?
no, I mean, for sure. And
Yeah.
I'm just it's the same thing. I think even on the team side, coming from like the fire service, I think that's what works so great is, I'm a captain on the fire service, but when I go to the task force, I'm just a rescue specialist, and I'm there to dig
Yeah.
and break concrete and like stay in my
Right.
lane and do what I have to do. And I think that's the mindset you just sort of you have to put into it. And I like the joke about the four engineers and the six outcomes. That sounds about right. But I mean,
Yeah.
as far as team dynamics go as well, and the culture behind a team, what do you think creates that strong bond or that strong culture in some of these teams that just make them fit?
Honestly, I think with there's that requirement to stay ready, the readiness requirement, and with that, is the routine training. I mentioned that the task forces generally have some quarterly trainings, and unfortunately, a lot of the efforts for conducting exercises and training together is impacted by available funding and things like that.
Of course.
But in general, I think with how we maintain routine training and exercises, particularly the exercises, because when we're doing full scale exercises, that's the closest thing to a real event that you can
Yeah.
engage in, and you're doing nighttime operations, and you're kind of getting to those fatigue points, and working 12-hour shifts,
Yeah.
and rotating, doing handoffs with other shift personnel, and working together. And it's beyond that, there's also some of these continuing education events where all of these teams also, you're off the pile, you don't have your rescue gear on, you're talking in rooms and kind of figuring out how can you improve things, and
I I think you're right on there. Good teams talk. I think they talk to each other and they strive to get better. And that's those after action reports and hey, what did the humility of hey, what did we get wrong and how
exactly,
can we
yeah.
get better? Yeah. That's an important piece to building out and sustaining those teams. Big picture wise, how has the collapse rescue world evolved over the last decade?
Well, I'd say the technology piece is probably the biggest one, and as fast as technology is advancing, and now we've got AI tools. Now we're talking,
Yeah.
let's stick AI with drones, and
Yeah.
size, probably fly a drone and put some AI capabilities in it and do monitoring from the air continuously and things like that. We're relying heavily on some more of these advanced tools for structural monitoring, like with remote sensors and things like that. We do have it's become an older system, but there are newer developments kind of on the horizon for wireless building monitoring. We
Wow.
actually do have a wireless building monitoring system that we use, but it's big and clunky and
Yeah.
heavy, and you have to go into a collapse zone to implement it. And so there's different things like that. Disasters like Champlain Towers and Surfside, they emphasize the need to integrate engineers and rescue teams intimately from early on to implement a lot of these technologies like the monitoring equipment that we're currently using. But yeah, I
Yeah.
see advancements coming on that, and hopefully we can get sufficient funding to get some of these new fancier tools to employ with our teams.
And along with the tools, I mean, things on the construction side are also changing. Are buildings becoming more difficult to rescue in these modern buildings with modern construction methods?
Yeah, I'd say, modern lightweight construction and highly engineered systems are strong under normal conditions, but they can fail suddenly and unpredictably, and it creates a much more complex, unstable debris field,
Yeah.
compared to older traditional construction methods.
And what concerns you the most about technical rescue and the future challenges in disaster response?
I'd say the increasing frequency of large scale catastrophic events. We don't see, one thing we look at with internally within our program, and this is kind of the more administrative funding side that I'm always battling with our headquarters for the different emergency response teams that we have. But a lot of these heavy structural collapse types disasters, those aren't as common. However, we've got a lot of aging infrastructure out there. Surfside's an example of in a high level salt level air
Yeah.
and corrosion potential on rebar if you're not doing proper maintenance of the structures. That incident did make some improvements to the inspection codes for condominiums, for example, and some of those requirements for maintenance. But yeah, I think those more frequent events. We're seeing hurricanes more frequently. The talk about global warming and things like that, and its impact with more frequent hurricanes and tornadoes
Yeah.
and uh, and things like that are creating more disasters that threaten to overwhelm our response capabilities. And so, with that aging and infrastructure in the path of some of these disasters, we're doing our best to keep everybody trained, but I think keeping, we need new blood to be brought in,
Yeah.
probably in all areas. And,
Yeah.
and so that's something that's also a challenge.
Yeah. Passing the torch on and making sure that
Right.
those,
Right.
those traits get passed on to people that can take that the reins and run with it, I guess.
That follows with our training as well. I mean, we are, I think we pride ourselves on keeping up with current events and adjusting our training to cover some new lessons learned, for example. But we've got the same most of the same instructors that we started off with back in the mid '90s, and
Yeah.
so we've got an aging instructor cadre as well that we need to build the bench and bring in some new experience there to carry the
That's
torch there as well.
That's absolutely an important point. I talked about I in the fire service and building our teams, special operation teams, I talk about succession and the need to have a plan to who is going to come behind you to make sure that that program can sustain and carry on and complete that mission. So that's absolutely a very important point. As far as collapse goes, what do you think the fire service in general still sort of misunderstands about collapse operations?
I think it's pretty common that taking time for engineering slows down the rescue. But you mentioned this earlier. I think, rushing in blindly to an unstable structure is a recipe for disaster, for secondary collapse, which pretty much will stop everything. And so that'll slow the initial rescue response, and it may even, diminish it because of potential lives lost during secondary collapses. And so
Right.
I think proper engineering assessment and shoring plans are exactly what allows the operation to proceed efficiently and safely.
Gotcha. And just some closing questions for you. What deployment or experience has stayed with you the most throughout your time?
That is a question that I'm asked quite a bit, and that's I'd probably say the Haiti deployment, and this is we touched on this a little bit just on how does training mimic what you would experience on a real event, and the challenges with that. And the biggest one is some of those things you see, like you'll see death, and you'll see what happens to people. And in Haiti, the owner of the structure survived that and was, but had family that was in it, had employees. And one of her family members was a security guard who watched over her son, who was a toddler at the time and was in the structure. And we got to the location where they were expected to be in, and they'd found them. And you could see I was monitoring the heavy equipment on the top of a rubble pile, which was a critical operation because we were delayering this site, and we had to give hand signals to an operator on how to carefully lift things to make our efforts to recover. And we got to this zone, and it was right on the edge of where an excavator, if it went past this line, it would have caused further collapse. There was voids below it. And so it was something that was a kind of a reality check. But what I observed was they located the security guard, and he was cradling the boy in his arms. And so you kind of get it was something that gets in your head a little bit. I had toddlers at the time, and you're seeing envisioning the last moments of these two lives. And so it caused a pause, but at the same time, I'm doing a job here, and this is that mindset we're talking about. And you've got to be thinking about, the safety of the personnel that are working there, and what you're called to do. And so that one has stuck with me, and it emphasizes the need to include some training elements that talk about the critical incident stress disorder, and some of what you might expect in that. And you can talk about it, but it's another thing to experience it. And so
I believe that is a growing theme in the FEMA USAR system. I think you're hearing more and more of that. I think even in some of the post-mission debriefs now, that's becoming a required part, which is, probably a good thing, considering you see something like that. So, and that resiliency is very important.
Absolutely.
You've had a storied career throughout your time. What advice would you give to a young firefighter or even a young engineer who's interested in disaster USAR?
We do offer training. We do for some, if someone, we often do these VIP days where they can come and observe and see. With new engineers that have interest in the structure specialist training, a lot of them will have this adventurous thought of, it'd be really a cool thing to support. And once they get to the training and we stick them in a hole, they now realize that I've got an issue in confined spaces, and so that kind of weeds them out. But for the young firefighter, I'd say, master your craft as a firefighter first, but take opportunities to study building construction. And if you want to go the STS route, of course, you need to get your degree in engineering and get licensed. But be a continuous learner, seek out mentors. I think that's just an important element to learn from others.
You brought up mentors, and I think in tech rescue, USAR, on anything, honestly, in a skill in life, like the role that a mentor plays in that position is incredibly important. And to have somebody to look up to and ask questions to is vital to that, to growing in your position. Did you have anyone that, you were able to look up to and call a mentor in your way up?
I'd say in high school, I wouldn't consider a mentor. It was my wrestling coach. He was a down to earth man. He was a godly man, and it was just he was a figure that spoke into the lives of the athletes he was coaching, and it was at a personal level, and it was something that stuck with me, and it somewhat shaped me in my pursuit of a career, even not necessarily towards fire service, but just in I guess character building. And so that was an early mentor. Once I got into college, there was a PhD structural professor, Dr. Richard Swagler. He was an incredible man, incredible structural engineer. And I think he actually got his start with the Corps of Engineers. And so that it was interesting that was an opportunity that presented itself. I didn't start with the Corps. I was with the Bureau of Reclamation right out of college, but he was a good mentor through the college learning experiences and of course, having some of those early interests in firefighting. I did have an uncle who was a firefighter early on, so that might have spurred some thoughts there. But those were mine.
Yeah. No, like I said, I think that's very important. And I'll leave you with one final question: Is it possible? Does the government have the technology to download the fog manual directly into my brain? Are we there yet?
We've got a PDF online and available right now, but you can stick it on your phone. That's about the best we could do right now. And I
All right.
suppose some smartwatches might be a little small to read, but
Yeah. Well,
but
it's a
yeah,
technology in process, we'll say. And when does that update? How many years? What's the time difference between that update?
it's the fog itself indicates that it's updated every few years. I think we're off a year or so with this last cycle. But there have been new developments and new techniques that were recently developed and even pitched to add to the fog. It's something that we're a little careful on because we're as a government agency we're not promoting specific products, but there are some key products like we design timber shores and things like that and have honed and mastered and made it economize the construction and minimize the number of pieces for shores. But there's also a lot of like hydraulic and pneumatic shores that are on fire trucks that are much more quickly accessible and can get put in place much more quickly. And so there's a lot of vendors that want, hey, can we put this in the fog? Put this in the fog. And so we've got a few names in there, but we're pretty careful on how we present that. And so, but there is some new, I think there's some trench shoring content. There's some new elements of how that's being done these days that we're trying to get in there, and some geotech type elements for the engineer to have some quick reference. That's a little longer answer, but every few years.
Yep.
We're when we get one published, I think the last one was May of 25. We had quickly found some things that we needed to fix and some things that we'd like to add. There's a new 6-post lace shore that's been the strongest shore ever tested. It it's got about 150,000 pounds it was supporting, and so that's now added to the new version of the fog. But
that is a monster.
That's a beast. That's a good safety zone if you need to.
Between you and me, and obviously the rest of whoever listens, I am miserable at shoring. It is my ultimate downfall. It's my ultimate downfall. So I'm going to keep your number on a speed dial. So whenever I'm on the field, I'll just FaceTime you.
Yeah. Well, we often get some questions on that, like why aren't we using screws? How many nails? And things like that. But
I'm sure you hear it all. But well, hey Jeff, I just want to say thank you so much for your time, and it was enlightening for me. I mean, I thought I knew, what structure specialists do, but I know there's a lot more that goes into that. So thank you very much for joining us, and we appreciate having you.
My pleasure.
All right. Well, hey, thanks for listening to the Rescue Lab podcast, and we'll catch you again with the next episode.